So pleasure to be with you all. It's an honor for me to be facilitating this panel. We've got, I think, a great group to talk about this topic. We've got industry represented, we've got academia represented, as well as one of our national labs. And with your permission, let me just provide a second of context, and then I'm going to have each of the panelists do some opening remarks, and then I'll have some questions to follow up with. But a little bit of context. The title of this is certainly the hydrogen topic. But let's talk about this in the context of decarbonization and broader efforts, whether it's CCS or other decarbonization efforts. And frankly, while this is a global challenge, I'm hopeful that we can maybe talk about the region a bit too, because we have a unique opportunity in this region, and many of us are coming from the region. So we'll try to balance that as well. The other point that we'll get into a little bit is making sure we talk about this in terms of different sectors: energy generation, industry, transportation, and maybe even the commercial and residential piece. So there's a lot of different tentacles to this, and I think we'll have no trouble filling up the time for sure. But it's a fascinating topic, and I'm excited to be part of this. So again, let me just ask you if you could, and I'll start with James, just some opening remarks on this general topic of the hydrogen opportunity, and then I'll come back with some specific questions.
Great, yeah, opportunity indeed. I think that's kind of the theme of what I wanted to get across. But first, just a quick introduction. My name is James McCone. I'm an associate professor of chemical engineering in the Chemical and Petroleum Engineering Department down the road at the University of Pittsburgh. I've been there for about 6 years, since 2016. So of course, as a professor there, I teach courses for undergraduate and graduate students, and I run a research laboratory. We do applied electrochemistry research with a significant focus on what is now very consistently and specifically termed green hydrogen production, which is electrolysis of water. We also pursue electrochemical technologies for hydrogen utilization, agnostic of the source of that hydrogen, and a little bit of work on energy storage as well. So in that context, I am approaching this conversation today a little bit self-consciously, because I'm cognizant of the fact that as an academic, I tend to focus on technologies that are, by definition, not ready for the marketplace. Right? And so I'd like to think that I can provide some perspective on what might be exciting and looking on the horizon, but I am also recognizing that there's a need and increasingly real resources being brought to bear on expanding available technologies of every stripe. And so, like I said, I'm sort of happy to lend my thoughts, particularly about sort of future-looking technology development, as well as maybe the vision that is filtering down into the university space as we are working with young people, undergraduate, graduate students, et cetera. And in that context, I do want to say that there's just never been a more exciting time to be involved in this field, right? I think that the landscape of available opportunity to scale up, expand, make available green, low-carbon hydrogen technologies of various types is very stimulating to young people. And the idea that they can get involved in both technology development, deployment, even policy sectors and so on, and really be part of the solution is clearly driving motivation for a lot of our young people. And what I like to say a lot as I go out and talk, even in the academic context, is I think that one of the things that would benefit our ability to attract talent into this space is to be able to project a positive, coherent, convincing vision about what the future can look like for people who are working in this space, for technology development, for job opportunities, and so forth. And I think the more that we can do for that, the better. So that's kind of the vision that I'm going to try to put forward as I'm
great. Thank you, James.
Conversation today.
Klaus?
Well, thank you. My name is Klaus Brun. I work for Elliott Group. We're a manufacturer of equipment, and so we're probably looking at this a little differently in that we're looking at infrastructure, right? I mean, hydrogen is produced, needs to be transported, needs to be stored. And let's be cognizant, I mean, there is no hydrogen economy right now. I mean, we're all talking about hydrogen economy, but it's something that's out there. We've been talking about it for 30 years. There's green hydrogen, blue hydrogen, all these different types of hydrogen. Blue hydrogen, in that sense, has been around on a local basis. Hydrogen has always been a local phenomenon. Hydrogen is difficult to produce. I mean, you make it with electrolyzers, you lose energy. It's difficult to transport, it's difficult to store. It's somewhat of an unsafe kind of medium, process fluid. So it's traditionally been handled as a local energy storage and transport medium. It's not an energy source, obviously. As such, now we're talking about hydrogen being used as an energy transport medium and storage medium on a national and global level, right? Which means you're going to have to transport it, you have to store it, and really the technology and the infrastructure for none of that exists at this point in time. So we can talk about green hydrogen, which is basically hydrogen produced from alternative energy sources, from curtailed energy sources. And there's very little production of that at this point in time. People are talking about it, but actually there is very little production. In the whole United States, there is not enough hydrogen from curtailed alternative energy sources to fill one small power plant, 150 megawatt power plant. There's not enough hydrogen of that in existence in the whole United States. One day, maybe there will be. Blue hydrogen's been around in refineries, petrochemical industry forever. And so we know how to make it, but blue hydrogen comes from fossil fuels. And then you have to do something with the CO2. You have to stick it in the ground somewhere. So that brings another totally different infrastructure question that we have to address, right? We're not just dealing now with hydrogen production, transport, and usage, but we're also dealing with carbon production, transport, and sticking it in the ground somewhere and hoping that it stays in the ground. So from an infrastructure perspective, which is kind of what we're interested in as a manufacturer of compressors and of turbo machinery that will ultimately have to develop machinery for this segment, that's very interesting because none of this infrastructure exists and none of this machinery really exists. So my perspective is probably going to be less policy, less global, but more of, okay, how do we address this infrastructure technology questions because the technology isn't there yet either.
Great, thank you, Klaus. And we will definitely come back and talk more about infrastructure. That's a meaty topic for sure. And Brian.
Yeah. Good afternoon, everyone. Brian Morelli, I'm the Associate Lab Director at the National Energy Technology Laboratory, specifically the Research and Innovation Center, which houses hundreds of scientists and engineers and has hundreds of millions of dollars in investment in infrastructure solely focused on this energy transition. As one of the 17 national laboratories, more importantly, one of the 3 applied laboratories, we have a significant focus on advancing research to development and more so towards deployment. So the opportunity in front of us with the hydrogen hubs and the hydrogen economy is something that's extremely exciting to us. We're very looking forward to leveraging our skills and capabilities to go from concept and opportunity to realization, and coupled with the opportunity provided by the BIL, IRA funding, and collaboration within the region and companies coming together, I'm really looking forward to the opportunity.
Great. There's a lot of different ways we could kind of start this off, but if you would mind, and I'll come back to you, Brian, if you don't mind. There's a lot of money out there being talked about for these funding opportunities that DOE's put out, not just in the infrastructure bill, but also in the more recent legislation. This region, among many, is competing for some of that money. Mm-hmm. So the company I work for, Into Market, we're part of what we call Appalachian Energy Future. That's the actual name for it. It's an industry-led consortium of companies interested in decarbonization. But interestingly, the companies in our consortium isn't going to be a funding submitter. Some of the companies will be. Our focus is more on trying to enable this broader decarbonization cluster. And so I guess the question, I'll start with you, Brian, if you could maybe just give a little bit of a 101 for what these upcoming FOAs are about, and then maybe we could talk together about the attractiveness of the FOA, but how do we also make sure we're not just focusing on the FOA, but also on the broader decarbonization opportunity?
So I think the overall goal and objective of the opportunity at hand is really the development and accelerating of infrastructure at demonstration and integrated scales. Something much beyond ever conceived, I think, in DOE or other office historically. So it's a generational opportunity. I think this region makes a lot of sense to host such a hub through this competitive process. Obviously, it has the resources in the short term to produce hydrogen. It has a great infrastructure already available to getting hydrogen from where it's produced to where it's needed. And obviously, there's a number of industrial consumers of hydrogen in the region. At the laboratory, we're really looking forward to working with people like Into Market and other consortiums on leveraging some of our capabilities more aligned with analyses. So how can we understand from an economic vantage point, from a market vantage point, where are the biggest opportunities for such investments, and how can we take the largest advantage of the opportunity at hand?
Right. And Klaus, if you wouldn't mind me turning to you on this question, coming from the industry perspective, and certainly we don't want you to share your strategies, but if you could share a little bit more about, kind of the industry perspective on this partnering opportunity and this pre-competitive topic that's come up before. How do we collectively develop this, interest in a larger cluster, and at the same time position companies to pursue funding opportunities in smaller consortia?
Yeah, I think the biggest challenge right now is that there isn't really a hydrogen market yet, right? So the hydrogen market that exists is primarily on the refinery petrochemical side, some chemical industry. You really have to, before you get people to commit to build substantial infrastructure to produce hydrogen and then transport it, which is very, very expensive, you have to make sure that there is a long-term offtake for this hydrogen available. And so then you have a limited number of opportunities. There's transportation, which requires significant infrastructure. You need to have hydrogen fueling stations, right? That doesn't exist other than in California yet. You have power industry, which is that's kind of like the low-hanging fruit. Put some hydrogen into your natural gas for combined cycle power plants, or build some other power plants that run on hydrogen. So that's kind of your low-hanging fruits, and that's kind of where I think government subsidies are currently talking about hydrogen subsidies for green hydrogen. That's where they're going. And then you have domestic use, but domestic use is very challenging from a safety perspective, right? So do you really want to have hydrogen in your local domestic distribution system beyond the city gate? I personally don't. I mean, I feel like I don't want to blow up my house quite yet. So I think the low-hanging fruit is, at this point in time, power generation. Power generation from the non-transportation carbon production perspective, 70% of the CO2 in the United States that is not related to transportation, so aviation and automobiles, comes from power generation. So that's a low-hanging fruit, gigantic market. Now you have to get the power plants to basically accept the hydrogen. The problem is that hydrogen is going to be expensive. You have to subsidize it and make it competitive to natural gas, because overall, from a regional perspective, natural gas is very, very cheap. So I think the challenges for DOE and others that are pushing this industry is not just to demonstrate, can we make it, but you're going to have to demonstrate, can you make it at a price level for not just 5 years, 10 years, but maybe even 20 or 30 years, because you build these power plants, they have a lifetime of 30 years, 40 years, right? So you have to demonstrate this hydrogen is going to be available to you for a long period of time at a low cost.
No, great point, Brian.
No, I was just going to add to that. So from the power side of things, turbine technology has the ability to accept small amounts of hydrogen already, so it's definitely a pathway there. Obviously, more technology development needs to be had to make those turbines capable of running on pure hydrogen. But Klaus, an area that maybe I'd like to hear your thoughts on that wasn't mentioned is those industries that really need process heat. So glass making, cement making, steel making could be another opportunity maybe for a shorter term consumer.
Yeah, and those are also probably low-hanging fruit. I mean, hydrogen is very easy to combust, right? It burns pretty much, even if you don't want it to burn,
yes.
Right? So if you can find localized opportunities for heating, even things like district heating is an opportunity. The other big challenge is to get your hydrogen from your production point to where you actually want to use it, because compression of hydrogen and transport of hydrogen is not easy. And so there's really two technologies that are being discussed. One is just dedicated hydrogen transportation system, and the other one is blend your hydrogen into natural gas, and I know DOE's been working on that for probably 20 years, 25 years. The challenge with that is how do you keep that then from going again into your domestic distribution, because the United States pipeline infrastructure is very interconnected, right? So you put hydrogen one place, it's going to come out at a different place. But I think that's an opportunity. And then you also have to then differentiate between, is it green hydrogen or is it blue hydrogen? Because if it is blue hydrogen, then you may as well transport your natural gas to where you need it, make hydrogen there, and then worry about the carbon dioxide. With green hydrogen, you're probably going to have to worry about a hydrogen infrastructure. With blue hydrogen, you would naturally continue to use the natural gas network and make the hydrogen where you actually need it.
And if I could maybe build on the point you brought up earlier, Klaus, and maybe we can't go deep into this, but I see this a lot in this particular region, and I think it's probably pretty universal as this topic comes up, not just in the business community, but in the general public. There's obviously a lot of confusion, fear, preconceived notions and such. I guess it's a question to you, and maybe this is something you want to start with, but I'll open it up to any of you, how do you see the engagement and the communication, the education playing into this in terms of developing regional hubs? What comes to mind?
Well, the Hindenburg did a lot of harm. Let's put it that way. The Hindenburg disaster did a lot of harm.
Challenger too.
Yeah.
In many ways, historical and in the moment. But I don't find it to be very difficult to overcome that sort of initial anxiety about the use of hydrogen more broadly, at least with respect to safety, or if that's part of the focus here. It doesn't take very much to sort of explain that we put a very explosive substance into our vehicles every day, and the conditions under which that's unsafe are very similar to the conditions under which hydrogen is unsafe. Now, there's differences. I think that depending on how specialized you are, you could argue those differences are subtle or that they're not subtle. But I think that isn't particularly difficult. I think there are tons of technical challenges to the effect of what was alluded to earlier about particularly hydrogen transportation, which is an area that even the sort of public-facing focus from DOE and others is not focusing on, right? Like you look at Hydrogen Shot as this sort of major push from the Department of Energy about decreasing the cost of hydrogen production, and nowhere within the scope of the specific Hydrogen Shot goals is there any explicit statement about cost or technology development for transportation, right? And I think that's a real significant consideration or maybe concern for moving forward.
Yeah, I think from an industrial setting, hydrogen usage is no problem. Again, we've been using hydrogen in the refinery sector and petrochemical sector for 100 years. But the domestic usage and even the automotive usage of hydrogen will pose significant safety challenges. Hydrogen is not that easy. The light gas, it comes out of small cracks, it's highly explosive, has a wide flammability range. All these things are not really things that lend it toward domestic usage. But on an industrial basis, I mean, we know how to deal with it. Mm-hmm. So that's not a problem at all. And so I think the education should be one to educate the industry first rather than the general public, and probably worry about that later.
I agree with my colleagues on what they said. I do think there's a campaign needed more broadly on outreach and socialization of the hydrogen topic to the consumer. People in this region will probably appreciate this. After living the shale gas boom over the past decade, a number of people thought it was rather safe, but there was a number of people who did not. And I think we should learn from that case and those examples and get out in front of the hydrogen topic more publicly.
And maybe to build on that, in the roundtables and outreach we've been doing, there's certainly a positive viewpoint related to the job opportunity. Mm-hmm. Although people want to see that that's real and how does it work, versus say the fence line community piece, which is how do we make sure that this is done in a way that we're concerned and dealing with the environment and the local population, and maybe this will lead to a little bit of discussion on just the collaboration model, because I think the importance of collaboration is also very pertinent to what you brought up, Klaus, related to infrastructure. Any thoughts, and maybe you can start with this, any thoughts in terms of the public-private partnership models that are relevant here and important in this topic?
Yeah, that's a great question. And actually my thinking about this has been evolving a little bit recently, particularly with the publishing of this FOA for the Hydrogen Hubs program, and sort of a very clear statement from the Department of Energy that the amount of money that's being put behind this, which is an order of magnitude or more than larger than I've seen from anything close to a comparable project historically, has been earmarked in a very, very specific way not to support early phase work, right? Nothing even up to the pilot scale. And so that poses an interesting, I don't know, we could say opportunity, but maybe challenge from the perspective of a university, right? Because how do you convince folks who are affiliated with the university, like myself, who are predominantly involved in pre-pilot research, to participate heavily in an effort that will provide no direct benefit to that part of their program? And I think that there actually is an answer to that question, and this is sort of where I've been thinking about recently, which is that universities still play a very important role as was alluded to in the last panel, kind of gathering place, an opportunity, a physical location in many cases, but also sort of a structure that can facilitate lots of conversation among both public and private players. We at universities tend to have a lot of professional connections across sectors and across company boundaries that people within those sectors and those companies may not feel so comfortable being able to access on a regular basis. So that's one piece I think is very helpful in the context of a role the university can play. The other, which is at least as important, is in workforce development, broadly defined, right? We're really interested, and this kind of comes back to the introduction that I shared about what's our vision, right? What's the vision for the industry that we're trying to build for the future? That's a vision that we need to be able to project to the young folks who are coming into their education at the university level or elsewhere. And it's a vision that we have to be able to communicate to educators so that they can tune, modify, develop curricula that will fit the needs of near term. I've got sophomores that I'm going to see later today, perhaps, and as well as more the long-term 10, 20-year time horizon that those same sophomores are thinking about as they're wondering about what level of job security they're going to have moving into the multi-decadal careers they hope to have.
Great. And Brian, I'm going to maybe build on this topic of collaboration, if you wouldn't mind. I think it sounds to me like NETL is playing a kind of a unique role in the way you're engaging. Could you talk a little bit about the support role you're providing for these efforts?
Yeah, similar to the role that you've talked about as a convening role, where we also play a role in that within the industry sector. But again, what we're trying to do is we're going to be teaming with hopefully a number of different opportunities. As a national lab, our goal is to make sure that whichever hubs are selected, that they're successful. And we're going to do everything within our capability area to make sure that happens. As an aside, I think DOE intends with the hubs to spur collaboration and partnership. They're constructed in a manner that is going to require integration along a value stream. And again, I think that's something the industry is not necessarily comfortable with doing historically. Mm-hmm. But I think, again, you put $4 billion out there as the opportunity, $8 billion in total, it's going to get people motivated to do so.
And to me, kind of building on that point, we have to remember that DOE is basically trying to create an interconnected network across the country. And that while there's competition around regional hubs, ultimately this needs to become an interconnected network. I talk regularly to connect the DMV in the Maryland, Virginia area to the Houston hub, and we're actually all looking for where are those areas of commonality where there's maybe some synergy in the long run, maybe not in the short run. So definitely, I think there's opportunity around kind of new definitions of collaboration. If I could maybe go back a little bit now to, you said early on, Klaus, that, rightly so, that hydrogen is this long-term opportunity. There's not really the demand for it yet. So we know we have to create more off-takers and more end users. But there's also these, especially in this region where we're talking about potentially blue hydrogen playing a major role, carbon sequestration is going to be a technology that's very relevant, not just for capturing the carbon dioxide out of hydrogen production, but also as a standalone mitigation to decarbonize the local region. So I'll just open this up. Would one or more of you maybe talk a little bit about the role you see carbon capture and sequestration playing, including where do we put it?
Yeah, I actually see a critical need for carbon capture hubs, more so than for hydrogen hubs. Because if we're really talking about the topic, it's called decarbonization. It's not hydrogen economy, right? We want to decarbonize our industry. So the common denominator is carbon dioxide. And if you're looking at green hydrogen, that's one thing, but green hydrogen is unfortunately somewhat still of a mythological beast, right? It doesn't quite exist yet. Blue hydrogen exists, and we can produce it in large quantities, and it makes actually quite a bit of sense especially in regions like this where you have natural gas in abundance. But then you do have to deal with the CO2. And for that, you have to develop a network and infrastructure also, pipelines, compressor stations, places where you want to stick it in the ground. And for that, it really does make sense to have centralized places where you can actually have one place where multiple power plants can have pipelines going to a centralized place to sequester CO2. That technology actually exists. Right? So I think from a short-term perspective, to decarbonize our generation industry, there's much more opportunity in continuing to run with, for example, natural gas, make hydrogen near the power plant. Then you have to deal with the CO2 and transport that back to a place where you sequester it. And actually what we're also seeing is now that the major oil and gas companies are recognizing some of these opportunities, and they're starting to talk about, okay, how can we monetize the business of sequestering CO2? Because most oil and gas companies are very familiar with drilling holes and putting things, in the ground. Right? So we're seeing a movement and discussion in the industry where a lot of companies, oil and gas companies primarily, are talking, okay, maybe I can sell this where I get paid for the offtake for CO2. We're seeing that now.
Yeah, to spur some of the advantages of capture and sequestration and hydrogen, IRA has two specific tax incentives in there. 45Q for abating carbon dioxide and one for producing hydrogen with certain CO2 footprints. So I think there's also, in addition to the money associated with the hydrogen hubs, there's also tax incentives available for these companies to really take advantage of the opportunity. And to build on what Paul said, both capture and storage have been practiced at demonstration scale. The thing that's really impeding its progress is still economics.
Yeah, but it is, and I've seen papers on this, from an energy perspective, a lot less energy to actually transport the CO2 to a place where you want to sequester it than actually transporting the hydrogen. And it basically comes down to the nature of hydrogen. There's probably too much detail there, but it's very energy intensive to transport hydrogen. It's not energy intensive to transport CO2. So it ends up being a lot easier really to transport your natural gas to where you need hydrogen, make hydrogen right there, and then transport your CO2, rather than producing hydrogen in a centralized place and trying to distribute it via a pipeline network.
All right, well, let me go back to basics a little bit, because I think we probably have a mixed audience in terms of people's familiarity with this topic. And when we talk about a hub, whether it's carbon capture or hydrogen or a combination of both, often people will say, well, where's the facility go? We aren't really talking about building a facility here, aren't we? We're talking more about a cluster or a network. Could one or more of you maybe touch on that a little bit in terms of how you see a cluster strategy working regionally? Where does it start? Kind of a chicken and egg problem, right? So where does it start, and then how do you do things in a way that are, at least on a micro level, economically viable, and then expand that into a larger cluster? Certainly, it's a tougher question. You're not going to give the answer here as much as just a little bit of an education on some of the the thought processes that need to be part of that.
Yes.
But, go ahead.
Oh, no, please.
You take it.
You're taking. No, you. This chicken and egg problem is very real. It's one thing to say there's a lot of financial opportunity, right? There's a lot of, let's say, really subsidy opportunity, right? There's some government money that can be brought to bear on a problem. There's a separate issue of, okay, what's the right scale, what's the right organization, et cetera. These things don't just self-organize. The point was raised, Klaus, I think, earlier, in particular, about where's the low-hanging fruit. And I think that that's probably the most important piece to consider very carefully, right? There's, and speaking from my perspective as a university researcher, there's tremendous incentive for us in the early stage R&D side to get eyes that are too big for our stomachs, so to speak, which is to say to focus a very large amount of our resources on what we see as the most important and the most difficult challenges. And so for perspective, the one example that I'll share that's very closely related to my work is carbon reuse through hydrogen production and then reaction of hydrogen with carbon dioxide to, say, regenerate things like liquid fuels, right? That's a holy grail among people in my field and in several subfields within chemical engineering. It's also one of the most fundamentally, from the pure thermodynamics, challenging things to undertake, and almost certainly not the first one that you would want to implement industrially. There's so much lower hanging fruit than that particular challenge. And so there can be a bit of a mismatch, right, between where's the enthusiasm and excitement in the early stage R&D development and where's the best place to begin deploying real technology. And so I think that it's worthwhile in the regional context for a huge proportion of that conversation to be around where is our, and when I say our, I mean regional specific, company specific, low-hanging fruit. And opportunities may be in things like steel production. Opportunities may be in, one of the collaborative activities that I engage in very regularly is a partnership with a company that makes specialty chemicals. And we're looking at some of the carbon intensity of specialty chemicals that are being produced in the product portfolio of this company. And what we are coming to realize is that some of the decarbonization strategies that we are looking at are much more viable potentially for that company in the fact that they operate with somewhat larger margins than in a commodity chemical company to be able to adopt even at relatively higher cost of electricity, say, for an electrified process. Much of what we're looking at specifically isn't hydrogen specific necessarily. There may even be lower hanging fruit than hydrogen in that context, right? But the important piece of that, I think, is the type of discussion that you engage in is where's the near-term opportunity? Where are the things that we can begin doing now, even if it's at a small scale, not world scale, to make a difference today and go from there.
Yeah, one quick comment on that is, DOE's role in technology development has been traditionally that to get a technology beyond the valley of death, right? That's the famous thing. Somebody really smart at a university develops a really cool idea, it makes sense, and it's been DOE's role to kind of take it beyond where it's beyond the valley of death. CO2 is beyond the valley of death, and DOE has actually spent over the last 25 years a lot of money on projects to demonstrate that. Right? Hydrogen is not beyond the valley of death. There is still a lot of technology that need to be developed. And from a chicken and egg perspective, any technology that's not beyond the valley of death, i.e. it's not proven on a pilot scale, on a reasonable large scale, is not bankable. Right? You cannot go to a bank and say, I want to take out a $100 million credit, $500 million credit to build a facility. The bank is just going to laugh you out of the door. Right? And the same with insurance. You can't build a power plant without insuring the power plant. But the insurance company, if the technology has not been demonstrated, is not insurable. So that's where DOE has come in a lot over the last 30, 40 years in various technology areas to get these technologies out of the valley of death. Mm-hmm. And that I see the same thing here with the technology hubs. It's not just to develop an initial infrastructure, but it's also to show a couple of smaller, mid-sized installations that you could probably manage somehow from a bankability and an insurance perspective to where the industry recognizes, okay, this actually works, now we can do larger scale.
Yeah, just maybe one thing to add. I think what you're going to see in the hydrogen hubs is you're going to see companies that come together who have decarbonization and sustainability as a core priority of their longer-term strategy. And what they're going to do, I believe, is use this opportunity to de-risk investing in their own strategy to help ensure that this is a reality. So I think that's what you're going to see happen in this, and then that success will propagate further, and I think that's the overall intent.
Yeah, it's going to be the Wild West for sure, and it's going to be interesting times coming up here. And speaking of time, we're about out of it. If you wouldn't mind, I'd like maybe just for each of you to have a closing comment around, whether it's advice for this group if they're in this space, or whether it's just your prediction of kind of what should we be focused on in the near term to start moving this forward? What's the whether it's low-hanging fruit or whether it's a factor we need to pay attention to? What's your piece of key advice in terms of how to bring this to life? Start with you.
Yeah. Okay. So I think that the message that I would put forward here is that it's easy to be a little bit cynical about green hydrogen in particular because it's, along with fuel cell technology, one of these on the very long list of things that you could look at a scientist at a university like myself and say, this has been 5 years away for the last 50 years. Right? And in this context, I think that green hydrogen in particular gets lumped in with fuel cell technology in a way that isn't quite appropriate. And I think that we can't really count out the possibility that we could really get close to these cost targets that DOE is putting forward. And if you can, then there would be an incredible opportunity. I say this as actually a product of one of the earlier DOE-funded moonshots, which is the Sunshot program. My postgraduate research was actually funded through that program. And what you saw there was an incredibly ambitious goal set at the beginning of a decade for the decrease in the cost of solar production. And through a lot of effort, both from DOE and from other forces that were in place in the private sector and in other countries and in several places, essentially met that goal within the decade timescale that they set. So I wouldn't count that out as a real remarkable opportunity. If you can meet some of these cost targets, it would be a real game changer for our ability to use hydrogen. With the caveat that I still think the transportation can be a bee in the bonnet of that whole scenario.
Yeah, I would look at it more from a perspective that I think blue hydrogen is our near-term opportunity. The technology there, where you produce it at the production side of your fossil fuel or at the end-use side, that can be debated, but I think it's going to be the end-use side. Green hydrogen, I kind of sort of disagree with you, because green hydrogen is only truly green hydrogen if it comes from zero carbon sources and if it is curtailed energy. Right? If it's not curtailed energy, then all you're doing is you're providing an opportunity for fossil fuel plants to fill the gap that you're using electricity for making hydrogen. So in that sense, it really doesn't make a whole lot of sense, because you're producing green hydrogen only when you have curtailed energy. Wouldn't you rather develop the electric infrastructure and storage infrastructure for electric rather than producing hydrogen where your round-trip efficiencies to get back to electricity is 40% at best? Right? So I'm very skeptical about green hydrogen. I'm very optimistic about blue hydrogen, because it really provides an opportunity to decarbonize the industry with the fuel source that we actually still have. So I think the focus there then is, okay, making hydrogen, but then what do we do with the CO2? And that's really the technology.
And frankly, I wish we had more time, because I think it would be an interesting, healthy debate on the green versus blue hydrogen. But we won't go there in the remaining time we have left, because it's a longer discussion, but I want to give you a chance.
Real quickly, and don't lose sight of why this is such an important topic, and it's really to fight climate change. You know, something that I think there's enough data points to illustrate this is a real thing, and something that we all need to own. The 2050 and 2035 goals set up by DOE and the administration on decarbonization are a pathway to achieve that. And I guess the biggest thing I would ask that we all think about as we move forward is thinking about that 2050 and 2035 goal, not how the energy sector looked in the past or how the energy sector looked in the future, but all of us get on board with the way the energy sector needs to look to achieve those targets.
I don't think it'd be a better way to close this off than that, because I think absolutely it's about that future opportunity, and hopefully that keeping that in mind is what's going to get folks to work together to achieve it. I hope you'll join me in thanking these great panelists for the time they've devoted with you. And I think each of you are going to be here for a while too for the lunch if people have individual questions.
Yeah.
Great. Well, thank you.